Right, and now we continue with differentiation, looking specifically at implicit differentiation and max and min problems. Okay, so let's start with implicit differentiation, and these are quite easy to see because basically you've got an expression that has got a whole lot of x's and y's in. Okay, and so if you remember, when you differentiate an expression that has an x in it, you differentiate it and you move along. But when you differentiate an expression that has y in it, what do? You differentiate the y and then you drop a dy dx. Okay, so let's have a look. Now, just to be warned that these kind of questions go for 10 to 12 marks. So they are definitely worth practicing and getting correct. Okay, so let's have a look. So if I differentiate the first term, I get 12y cubed. Because it's y, I drop a dy dx. I move along to the next term. I differentiate 4x, gives me 4. Because it's x, I just move swiftly along. And now I've got minus the product of two expressions here. So remember, don't forget your other little sneaky rules. So what are you going to do? You're going to have the product rule here. Now, if there's a minus sign, just remember to open the bracket. Okay, otherwise you're going to make an error with your signs. So now, how does the product rule go? I differentiate the first, so I get 2x. I leave the second, sine y, plus leave the first, x squared, differentiate the second. Now, when I differentiate sine y, I get cos y. I haven't differentiated anything with y yet, but then I multiply by the derivative of the angle, which is 1, and because it was a y, I drop a dy dx. Okay, then I go to the next term, minus 4. What's the derivative of e to the y? Also e to the y. I haven't differentiated y yet. Then I differentiate the power. Okay, and what's the derivative of the power? The derivative of y is 1, and because it was y, I drop a dy dx. Equals to, what's the derivative of a constant? 0. Okay, just that line is worth many, many marks. Okay, all right, then the next step. Now, if you ask to find the equation of the tangent at the point P1 naught, there's a long way of doing this, and then there's a nice sneaky shortcut. Okay, I'm going to show you the long way first, and then I'm going to show you how to do the shortcut. So if I want you to find dy dx, I could make you simplify this. Okay, and then make sure that all the terms with dy dx is on the left-hand side, and everything else that doesn't have a dy dx on the right-hand side, I then divide through and I get an expression for dy dx. I then substitute the point in 1, 0, and I get a gradient of 4/5. Okay, so you have to do this method if they say to you, if the question is part A, find an expression for dy dx. Okay, then there's no shortcut, and that is how you do it. If I'm asking you to find the equation of the tangent, remember you need a gradient and a point, and so you sub in either using this formula or y equals mx plus c, whichever you prefer. Okay, but I want to show you the shortcut is that as soon as you finish this step here, I would substitute in straight away. Okay, so I'm going to sub in the point 1, 0. So basically, when I see an x, I'm going to put a 1 in, and when I see a y, I'm going to put a 0 in, and I'm going to just substitute all the way through. Okay, and if you want to replace dy dx with m for gradient, that's all right. Okay, now what's nice about substituting in straight away is that quite a few terms actually disappear, because you can see that this whole term here is going to equal to 0, so that's going to disappear from your equation. That's still going to stay. This part here, the sign of naught is naught, so that whole expression is going to disappear. Then I go to this term here, and remember cos of naught is 1, so this term is not going to disappear, and e to the naught is also 1, so that term is not going to disappear. So I can simplify this to my 4 minus dy dx minus 4 dy dx, and when I simplify that or solve for dy dx, I end up with the same answer of dy dx equals 4/5, and I've saved a whole lot of time by not having to do all this and taking care not to make silly errors. Okay, all right, and obviously once I'm there, I then sub in my point, and I get to the same conclusion. Okay. All right, so now I look at the next example of an implicit differentiation. It's saying what is dy dx at the point 2, 1 if dy dx exists and you have the curve y squared minus 1 equals ln x minus 1. Okay, by stating that dy dx exists, you don't really need to put in any restrictions. But what would your restrictions be? That x minus y has to be greater than 0 or x greater than y. Okay, but let's get going. So if I'm differentiating this, I can see it's an implicit differentiation. So what do? I go one term at a time. So the derivative is 2y. Because it's y, I drop a dy dx. Minus, what's a derivative of a constant? 0. Equals, be careful in this next step. So if I've got ln x minus y, my derivative, when I differentiate this, I'm going to have 1 over x minus y. I haven't differentiated anything with y yet, so I don't drop a dy dx, okay? And then I differentiate the denominator. And when I differentiate the denominator, I'm going to have the derivative of x is 1 minus the derivative of y, which is also 1. And because it's y, I drop a dy dx. Okay, I see in many of these type of questions, especially with trig, ln, e to the powers, people, as soon as they see a y, they tend to drop dy dx's everywhere. Okay, remember, it's only when you're differentiating that actual variable of y. All right, then we're not going to rearrange. We're going to go straight into it, and we're going to substitute the point 2, 1 in. So wherever you see an x, you're going to put 2, and y, you're going to put 1, and you're going to solve a nice grade 8 problem, and you're going to solve for dy dx, and you get your gradient to be a third. Okay, I hope that makes sense. All right, the next thing I want to look at is max and min problems. Okay, now it is very important that when you want the maximum area, your plan is to find a formula for the area, differentiate it, make it equal to 0. If you want maximum volume, you want to get a formula for the volume, you differentiate, you make equal to 0. If you want maximum length, you get a formula for the length, you differentiate, you make it equal to 0. Okay, so let's have a look at this. I have got a rectangle is drawn inside of a radius 10 centimeters. As soon as there's a radius, the word radius, I know radius is sneaky, and so that means that if that's a radius of 10, then that line then is also 10. Okay, please, radius or radii, they pop up everywhere and they're sneaky. You just need to know one of them to have to know all the others. Okay, you also know that you've got the center M, and so therefore when I'm looking at the area of the rectangle, I'm thinking it's this whole length times breadth, and this whole length would be made up of 2 of AM. Okay, so let's see what we're going to do. All right, so the first thing we're going to do is we're going to put in our radius of 10, okay? All right, then a warning. As soon as you get given an angle of theta, you know you are going to introduce trig, okay? So now you're thinking, all right, well, I need to know the length of this. I need to know the length of this side so that I can get the length of the big side. Okay, so what is the length of AM? Well, just using trig ratio, I can say that AM over 10 adjacent over hypotenuse is equal to the cos of theta. And similarly, I can say that AB over the hypotenuse of 10 is the opposite over the hypotenuse is sine theta. And then I'm good to go, because then I can say that the area of this rectangle is made up of 2 of these lengths of AM times the breadth AB. Okay, and then I replace AM with 10 cos theta, and I replace AB with 10 sine theta. When I simplify this, I get 200 sine theta cos theta. Now remember, we want to find the maximum area. So that means we want to differentiate this and make it equal to 0. Now, if I differentiate it at this point, I'm going to have to use the product rule. But I can see that I can actually make it simpler, because I can see I could actually say that this is 100 times 2 sine theta cos theta, which is the same as 100 sine 2 theta. It is always easier to differentiate a single trig ratio than having to use the product rule. Obviously, you'll get the same answer, but if you can make it simpler, why not? Okay, so let's go and we're going to differentiate. So dA d theta, it's 100 times the derivative of sine 2 theta, which is cos 2 theta times 2. Hopefully you can do that in your sleep by now, is equal to 0 because I'm maximizing it. And so therefore I'm going to divide through by 200 and I end up with cos 2 theta equals 0. Now this is normally, the next step would be to follow the general solution. But I'm just looking at this triangle and I can see that it is going to be an acute angle. Okay, and so therefore I can just say shift cos 0 and I end up with 2 theta equal to pi over 2, which means theta is equal to pi over 4. Don't forget you've got to be in radian measure when you do these. Okay, I hope that makes sense. All right, so then we often get questions where you get shapes inside a graph. I always think these look worse than they are. In fact, they're the easiest ones because you've actually you've given both your variables because you've given the formula for the y. So in other words, you know what your y value is, and the x value is whatever OB is. So let's have a look at. You've got many rectangles can be inscribed under the curve y equals e to the negative x. Determine the coordinates of A when the rectangle OBAC has maximum area. So I want to get the area, the maximum area for this rectangle. So remember, if I want maximum area, I first need a formula for area. Then I differentiate, then I make it equal to 0. So let's look what we've got. We've got area we know is x times y. They've already given us the formula for y. So they've already given us the groundwork for y. It's equal to e to the negative x. And so I just replace y with e to the negative x. I differentiate. Now what rule am I going to use? The product rule. Differentiate the first, leave the second. Plus, leave the first, differentiate the second expression. What do I then do? I make that equal to 0. I take out a common e to the negative x. I fix it up. 1 minus x. Remember, e to the negative x cannot equal to 0. So therefore, x is equal to 1. The question's not just asking me for what is the x value. It's not even asking me for the dimensions of the rectangle. Otherwise, I would leave it as x and the y. But it's asking me for the coordinates of A, for which this will be a maximum. And so therefore, the coordinates are when x is 1, how do I get my y value? I sub it into my original to get my y. Okay, happy. All right, this is a wonderful question. Okay, if I look at this question, it says it's quite a tricky one. It says the distance that a particle moves is given by the equation d equals 4 sine 2x. Okay, looks nice and easy. And the problem is, let's go to question 1, and it says, show that the velocity is v equals to root 16 minus d squared. So you're thinking, this is distance. I want the velocity, nice and easy. The velocity is the derivative of the distance because it's change in distance over change in time. So what do? I go dx and I differentiate my function. And what do I get? 4 times the derivative of sine 2x, which is cos 2x times 2. Simplified gives me 8 cos 2x. Okay, now problem, because I've got my derivative to be 8 cos 2x, I go to the question, that's not what they asked. Okay, so if ever I want to turn trig into algebra, I have to use my right-angled Pythagoras triangle using trig ratios. So I go back to the question and I say, hold on, I'm going to write this as d over 4 equals sine 2x, or sine 2x equals d over 4, because then when I put this in a right-angled triangle, I can say that I'm going to make 2x my angle, and then the ratio of sine is the opposite over the hypotenuse. So I can say the sine opposite that angle 2x is d, the side, over the hypotenuse 4. Which means that by Pythagoras, I'm going to work out the third side by saying the hypotenuse squared minus that side squared gives me 16 minus d squared. It's now starting to look a little bit better. Okay. All right. Now remember, we're going to go back and say, hold on, v, the velocity, is equal to 8 cos 2x. So I need the algebra for what cos 2x is equal to. So what is cos 2x equal to? The adjacent over the hypotenuse. Okay, once I know that, I can then say that the velocity is equal to 8 times that, and you can see straight away that it's going to be what you asked to find. Okay, so just remember, if you need to go from trig into algebra, think of your right angled triangle and use your normal trig ratios. Okay, all right, the next question is find the maximum distance that the particle moves. Now remember, the maximum distance, if we want to find maximum distance, we need a formula for the distance. We differentiate that, which we've already done, okay, and we make that equal to naught. So in this particular question, there's no more differentiating. We've already done it, okay, so we want to actually just solve where the derivative, which is the velocity, is 2 root 16 minus d squared equals naught, which is also why they asked you in part 1 to show that the velocity is that, so that if you can't do part 1, you can still do part 2. You've got to be clever when you write this exam. Okay, so that if you can't do that, you can still do part 2. So if I want the maximum distance, if I'd wanted maximum velocity, what would I have done? I would have then differentiated this expression and made it equal to naught. But I want maximum distance, so I want the derivative of the distance, which is that equation there. I make equal to naught, I square both sides, well, not yet. I square both sides and factorize, and you would have 4 minus d, 4 plus d, but obviously d is equal to 4 because we're working with distance. Okay, all right. It is quite a tricky question, but I promise you, practice, practice, practice. Okay, and obviously remember, you can always pause and go back and have a look. All right, good luck.